Okay.
Now go.
Okay, so Ito's lemma. Okay, so to use Ito's lemma, you need to understand a basic understanding of partial derivatives. And what we're doing with partial derivatives, if you have a function with several variables, what you do is you find its derivative in respect to one variable, and then from there, you just leave the other variables as a constant, okay? So then, what we're going to do, through Ito's lemma, we find that P is equal to del F over del T. Del is the Greek letter that is going to represent partial derivatives. So del F over del T plus del F over del S times A plus 1/2 del F over del S to the second order times B squared. Okay? And Q is equal to del F over del S times B. Okay. So, what happens here is that Ito's lemma is crucial in deriving differential equations for the value of a derivative for derivative securities, such as stock price. Okay, so now we have that, and what we're going to do next now to be able to find that relationship between A and B and P and Q is derivate. And to do that, we are going to use what is known the method of a Taylor series. Okay. So, by doing that, we find that DC is equal to del F over del T times dt plus del F over del T, that's wrong. Del F over del S ds plus 1/2 del F over del S to the second order times B, not B, ds squared plus del to F to the second power over del S del T ds dt plus 1/2 del F over del T to the second order times dt squared plus higher order terms. Okay, so now we have this equation. What can we do with it? Well, what we're going to do is you have to remember that ds is equal to a dt plus b dz. And dz is equal to vw times dt to the 1/2. And remember, w is the standard normal variable, and v is a scalar. Okay? So what you're going to do next is you want to take these ds and so vw times dt to the 1/2 and adt plus bdz, and then substitute them into the equation, and then do exponentials and product terms, and what you come up with, that you'll find what dc is in a much smaller thing. Oh, and don't forget that since dc is a quadratic equation, that means those higher order terms, do you remember those? Those higher order terms will go to 0, because if you have a quadratic, anything higher than second order is just going to be 0. Okay. So what you end up getting once you do all that is that DC.
Okay, stop. You moved.
Yeah, I know, because